This is continuing 1.5 and this is 1.5b, and our goal is I can use the discriminant to determine the number and kind of roots that we have. So the discriminant, well, first of all, we'll talk about exactly what the discriminant is because it's actually a little formula. But when we talk about roots, the kinds of roots, we often say the nature of the roots. So when we solve quadratic equations, we are finding its roots, also called zeros and x-intercepts. We talked about that last day. And there are three possibilities for roots. Okay, one of the possibilities is it's imaginary. What that means, it's not that I can't calculate something, because I can calculate something. It just means it will never cross the x-axis. Okay, so in other words, it has no x-intercepts. The next kind are what we call real and distinct. Another word for distinct means different. So it means it's crossing that x-axis at two different points. And the third one is what we call real and equal. And really what's happening is it's crossing at one point. So if it's only crossing at one point, it means the vertex is on that x-axis. So the types that turn out to be these are the ones that are like the perfect square type questions. Perfect squares will have two roots that are identical, and my vertex will be on the x-axis. So let's take a look at using the discriminant and what it's like. Okay, so first of all, the discriminant is, didn't want to do that. The discriminant is the value under the square root of the quadratic formula. And let's put that up to the other side. So notice it says d equals b squared minus 4ac. There is not a square root around this. Okay, so the discriminant is what is underneath the square root, but it doesn't include the square root sign, so it's not a radical. So a couple different things. We know that d is less than 0, the roots are imaginary. If d is greater than 0, the roots are real and distinct. And if d is 0, the roots are real and equal. All right. So when we look at the table that you have in front of you on the second page, we have an equation. We have three different equations. The next column, we're going to calculate the discriminant. And remember, the discriminant equals b squared minus 4ac. We're going to talk about what kind of roots that creates. And we're going to take a look at what the graph actually looks like in that case. So if I look at this first one and we actually calculate it, again, I can go a is 1, b is -6, and c equals 5. And we actually calculate our discriminant. Now, because I have the formula just above there, I'm not going to require us to write it down each time. So b, so we have -6 squared minus 4 times 1 times 5. Again, do the calculations. We end up with 36 minus 20, so we have 16. Okay, so that tells me it is greater than 0. So I know I have real and distinct roots, or different roots crossing in two different places. And actually, I have the actual graph here, and I'm just going to show it to you. So that is the actual graph of this. Now, in your notes, obviously, you're just going to put it like this, so you can see that it is crossing in two very distinct points, here and here. So that's because it's greater than 0, the discriminant, it crosses at two places. Now, the second example, let's try it, and we can see that our discriminant this time again is -6 squared minus 4 times 1 times 9, and we end up with 36 again, minus the 36, so we end up with 0. So what that means is we have, again, real roots, but this time they're equal. Okay, and so if we take a look at it, and again, I have created the actual graph here, you can see that it's crossing the vertex only at one place. So in your note, what you're going to do is you're going to actually put it here, and there's my parabola. Now let's take a little closer look at that equation. If you look at that equation, you can see that it is a perfect square of x minus 3 equals 0. So you can see that that it is a perfect square that I talked about from the previous page. Now the last example, if we calculate its discriminant, we end up again with negative 6 squared minus 4 times 1 times 12. And when we do that, we end up with 36 minus 48, and we end up with a negative number this time. So according to our information from the first page, we know that it's imaginary. Now, imaginary roots, what it means is there's no, sorry, that should be a no real roots. Okay, so no real roots. What that means, if I actually go to graph that parabola, and I'm just going to bring up the graph so you can see. Here it is here. You can see that here's the x-axis along here, and you can see that this parabola, its vertex is higher than the x-axis, and the parabola is opening up. So there's no way that it's ever going to touch that x-axis. So that's why we say that there are no real roots. So the types of questions that you would be asked, one very basic one is determine the number and kind of roots. You might even say determine the discriminant and then state what kind of roots you have. Either way, it'll be a question similar to that. So I'm going to start with the discriminant, b squared minus 4ac. I'm going to substitute in my values for a, b, and c, and then actually do my calculations. So we have 25 plus 164, so we have 189. So because it's greater than 0, I know that I have real and distinct roots. So that's a really basic type question. Then we get into things that are going to make us think a little bit. Here what we have is determine the value or values of k that will produce real and equal roots. So here's our equation, and to start an equation like this, first of all, I'm going to talk about what does a equal, what does b, and what does c equal. If we look here, a is 2, b is negative 1, but my c is this here, so it's going to be k plus 1. So now when I use my discriminant formula, I'm going to make sure that for c that I'm using this k plus 1 in it. So that's the first thing. I also, real and equal roots tells me that my discriminant must equal 0. So I know that d equals 0, and I also know that d has to be b squared minus 4ac. So substituting those values, all those values in, we have 0 equals negative 1 squared minus 4 times 2 times k plus 1. So again, it's a matter of doing the arithmetic. So negative 4 times 2 is 8 times k, negative 8k, and we end up with a negative 8. All right, so now what we need to do is we need to gather like terms. So we're solving for k, remember. So 0 equals, so we have a negative 7 minus 8k. Get the k's to the one side, and then divide both sides by 8. So we end up with one value. If k equals negative 7/8, then I know that that equation they gave me to start with, this one up here, that if this whole part, if this k actually, just the k was negative 7/8, I would have real and equal roots. Okay, so those questions are the ones that might give you a little bit more difficulty. We have a few to try in class tomorrow, so if you have any issues, make sure you're asking for some assistance.